Hello accounts people, time to have a look at costs by behaviour. We're going to look at variable, fixed and semi-variable costs. So, quick introduction first. Variable costs are the same per unit. They vary with levels of output. So best example, materials, it's £2 per unit in this case. Could also be direct labour cost, or we can also have a variable overhead, we could have packaging, all sorts of other costs. The more we make, or the more the cost goes up. But it goes up consistently. So in this case, if I made 100 units, my material cost at £2 each works out at £200. If I make more units, so now an extra 200 units, 300 times £2, £600 total variable cost, still £2 per unit. Fixed costs, these are the ones that are the same for different levels of output. So best example, rent a production machinery, it's £2,000 per year. We can make more or less, but the total bill stays the same, it's still £2,000. But the cost per unit will change. So if I made 2,000 units, £2,000 divided by 2,000 units works out £1 per unit. If I made twice as many units because I'm busy, that £2,000 for 4,000 units, it works out at 50p per unit. Economies of scale. Semi-variable costs then, these are slightly more awkward because they're part fixed, part variable. Lots of examples around, they're very common in the real world. Labour costs, when a bonus per unit is included, so our staff member here is paid £10,000 per year fixed and gets £2 per unit for production. Other examples, things like a telephone line is often quoted. You've got a rental of the line which is fixed, and then a call charge, so much per minute. This is a fairly extreme example because what we've got is 200 units being made, so we've got the £10,000, the bonus bit, the extra bit, £2 times 200 is 400, total of 10,400, which works out at £52 per unit. However, if our employee was a little bit more efficient and actually made 2,000 units in the same time period, it would be the £10,000 basic, but now it's £2 times 2,000, that's 4,000, so adds up to a total of £14,000. 14,000 divided by 2,000, it goes down to £7 per unit. The reduction in the cost per unit is because of the fixed part. So putting this onto a graph then, so what we've got here is all three actually on the same graph. We've got different output levels going along the bottom and different costs. So our variable cost, the blue line, £25 per unit, starts off down here. 0 times 25 is 0. 1,000 times 25, that's what goes up to £25,000. Nice straight line. Our fixed cost is also a straight line, but actually, even if you make 0 units, we've still got that £5,000 cost. If you make 1,000 units, it's still £5,000 cost. So it just goes across in a nice straight line. And then our semi-variable with its fixed bit and its variable bit. So because of the fixed bit, it starts here, that's actually at 2,000, and then it goes up, not as steep as the variable cost because it's only £20 per unit. So on top of the fixed bit, sometimes we show that separately, it goes all the way up to 22,000 in this case as a slightly shallower amount. We're going to use these numbers later when we split it. So let's do some calculations on it then. So we have a variable cost of £20 per unit, fixed cost 10,000, and a semi-variable, that's the fixed bit, that's the variable bit. So if we start adding this in, we can do variable cost will be the output level times our variable cost of 20. Our fixed, no need to use a formula for that because it's always going to be 10,000. And the fixed part, the semi-variable, is going to stay the same. But the variable part of the semi-variable, back to the output level, times the cost, £2,000 at £4 per unit. So if we add that up, comes to £24,000, and then we can just follow this across. So notice we've gone evenly, but then I've done an extreme one at the end. You can see the variable cost going up in regular amounts and then big jump because we've gone from 2,000 to 40,000, but the fixed is still 10,000, and this part of the semi-variable cost is still 2,000, and then the variable part of that with a big jump at the end as we do a 20 times output jump. If we did it per unit, then we take the cost, divide it by the output level. So it starts off at £48 per unit. What we're expecting to see is it going down per unit because of the fixed element. This one's gone down to £24.30. It will never go below £24 because it can't go below the variable cost of 20 and that part of the semi-variable, the 40. So it gets closer and closer to £24, but never hits it and never goes below it. Doing the calculations in reverse then, so another version of the question, you've got the numbers and we've got to try and work out what cost it was. So not rocket science this, because I've kept it fairly simple numbers. Well, all we've got here is we've got 1,000 units and a total cost. So the only thing we can do to try and help us is take the total cost, and that gives us £2.50 per unit. And if we take the next line, but must be a typo, because that's also £2.50 per unit. So if it's the same per unit regardless of output, it must be a variable cost. So this one then, we've got the number of units, we've got a cost per unit. So again, all we can do just to see if it helps us, that's better, £10,000. And if we do 2,500 times 4, we also get 10,000. So that means the total cost is the same regardless of output. We've made more, but the cost stays the same. So that makes it a fixed. So it's pretty obvious what the third one's going to be, especially as we've already used the numbers in the graph. But we can prove it. Well, all we can actually do again is take the cost, divide by the number of units. That works out at £30 per unit. And that one's less per unit, so it isn't fixed because it goes from 6 to 14,000. It isn't variable because it doesn't stay the same per unit. In fact, it drops just like the pattern we saw on the variable costs previously. So we could test it, we can actually work out exactly what it is. We know the answers from our first graph because we use the same numbers, but this is the technique. And it's called the HiLo technique, hence the words high and low. And what we do know is we know the cost at a low level, 200 units of production, £6,000 cost. We've also got 600 units cost us £14,000, so that's our high value. So what we do know is those extra 400 units cost us an extra £8,000. That is the variable element coming into action because the fixed bit was still fixed. So if we take 8,000 divided by 400, that's per unit, that gives us our variable cost per unit. So that's half the battle done. We've worked out our variable element. So now we go to our high value. We use the 600, and if we take our cost per unit times the number of units, that will be our variable element, or total of the variable element. So of that £14,000, £12,000 was variable. So if that's the total, the difference has to be the fixed part. So 14,000 minus 12,000, it must be £2,000 fixed and £20 variable cost. So if we go and check it at the low level, so that's our low level of output, so 200 units. We know that if we do 200 times 20, we get our variable. If we put in our fixed, when we add them up, we've got back to our £6,000, so that's the number that was up here, our total cost, which means we've checked our sums and we know that we've split the semi-variable up correctly.